Solution of differential equations. We'll be taking three differential equations for three different forms. The first one is y double prime plus 3y prime plus 2y equals 0. Usual format is like you can say y equals e to the mx is the solution. So then y prime will be m e to the mx and y double prime will be m squared e to the mx. If you know derivatives, then you can easily understand. When you plug all this here, we get m squared plus 3m plus 2 times e to the mx equals 0. So we can drop the term e to the mx. We get m squared 3m plus 2 equals 0. Now factor this trinomial. You will find m plus 2 times m plus 1 equals 0. So then m equals -2 and -1. These zeros are real and distinct. So the general solution of this differential equation is c1 e to the, you can write -2t plus c2 e to the -t. Or first you can write c1 e to the -t and then plus c2 e to the -2. It doesn't matter. Okay, so we have seen our first example that goes with roots are real and distinct. Now we will take the second one. The second one, if you go same way, your characteristic equation will be m squared plus 6m plus 9 equals 0. When you factor this trinomial, it will be m plus 3 times m plus 3. So we see our roots are -3 and -3. When you write the solutions yt, that will be c1 e to the -3t plus c2 e to the -3t. If you try to write like this, then c1 and c2 will be combined, and it doesn't work that way since we have repeated. So we put a t here, or you can put t in with c1, doesn't matter. So we got this solution when the roots are repeated. Next we are going to the third differential equation, m squared minus 4m plus 13. So then m is not factorable with real roots, we can see. So minus b, so b is -4, so that gives me 4 here. Plus minus, -4 squared will make it 16, minus 4ac, 4 times 1 times 13, that gives me 52 over 2 times a is 1. So after simplification, you find it 4 plus or minus 6i over 2. Because 16 minus 52 is -36. So when you take it outside the radical sign, it will come out as 6, and then the square root of -1 produces I. So you can see the roots are complex. You get 2 plus or minus 3i. And you write your solution like this. Yt is equals e to the 2t, that's the real part. And then we write here c1 for the complex portion. We go with sine cosine. Cosine 3t plus c2 sine 3t. So we have seen the solution of these three different differential equations. The first one gives us real and distinct roots, so we write one way. Then the second example, we have repeated roots, or you can say real and equal roots. That's why we write another format. And then in number 3, we are writing complex numbers. So the real part, you have 2 that comes out with e to the 2t, and then the imaginary part 3i that goes with c1 cosine 3t plus c2 sine 3t. Thank you.